Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to the lecture 3 of module 2 of Advanced Aquaculture Technology course. I am Professor Gauravdhar Bhaumik from Agriculture and Food Engineering Department, IIT Kharagpur. So these are the concepts that will be covered in this particular lecture material: the introduction to the recirculatory aquaculture system, the components associated with it, the fish cultures, what are the fish that we normally culture in RS technology, and merits and demerits of RS technology in general. As we already have some basic idea about what is recirculating aquaculture systems, as we have already discussed in earlier lectures in brief. So it's actually a recirculatory aquaculture system. It's a land-based closed system used for culturing the aquatic organisms. It involves the rearing of fishes in indoor or outdoor tanks within a controlled environment. It involves the recycling and reuse of the waste culture water after mechanical biological filtration or the both, and the removal of the substandard solid, definitely by means of mechanical filtration process. It normally uses a very minimal amount of land and water because it reuse the water which is circulating over the in its units. It involves the addition of new water only to make up for the evaporation loss, splash out, and that uses to remove the waste materials. So nowadays even the evaporation loss has been also somehow bypassed, because the whatever the controlled environment that the system has been designed nowadays by in different countries, the evaporation loss is also being minimized by capturing that evaporated water, evaporated moisture in the air circulating units, air circulation units, and they actually condensed it back, and they will put that water is actually given back to the systems. So that's how the technology advancement is been taking place in aquaculture sectors, and that's how evaporation loss, like the water which is due to the evaporation loss, is also being somehow it's been made up by the system itself. It in general, recirculating aquaculture system, it reduces the environmental impact and it improve the food security. So how it improves the food security? Because it provides us the additional amount of, because we normally do the intensive aquaculture system in RS technology utilizing this RS units. So and also the environmental point of view, also less water uses, and also the whatever the effluent, whatever the pollutant that is being generated from the culture of the aquatic species, that is being taken care by the treatment unit itself. So we are not throwing that water out in the surface water bodies, which will create nuisances in the system and nuisances in their biological ecosystem and all. So we try to that's why RS technology has been preferred all over the world. The feed that is used, it's a high protein feed with all essential minerals and vitamins we try to produce, and we try to introduce it to our recirculating aquaculture systems for maximum output. The species that is being cultured in RS systems, it's mainly the barramundi, bhetki, cobia, silver or Indian pompano, tilapia, pearl spot or carmine, pangasus, and the rainbow trout, etc., etc. So the components that involves with the RS is mainly the tanks, like the grow out tanks, the settling tanks, the water storage tanks, and the overhead tanks. There are pumping units which are also the part of a RS unit, which are actually pumping the water from the aquaculture wastewater that is coming out of the system to the different filtration units. Then the filtration unit comes, where the suspended solid filtration, suspended solid removal is happening in the mechanical filters. The grass wool on the muslin clothes filter, drum filter, biofilters, where normally the bioconversion of the pollutants to the favorable byproducts will happen. It normally happens in the biofilters. Then the UV unit to further get rid of all the unwanted microorganisms from the from the wastewater. Then the sludge and settlable solid collectors are also there, where whatever the filtered filtered solids which are actually taken out from the system, that collector of there is a system, there is a container where we want to collect those sludge and all, and this sludge is actually sometimes beneficial because it is very rich in nutrients. So you can utilize it for different purposes like biofertilizers and etc. After obviously you can go for drying and etc., and after the drying is done, then it can be used for different other purposes as well, production of biogas, and also it is possible in certain cases. The aeration and the oxygenation unit, which is very like one of the major component, because you need to provide dissolved oxygen to your aerator to your aquatic species all the time, because unless and until they are having ample amount of oxygen present in the system, and because we are doing intensive aquaculture, because we are not introducing any natural natural fertilization system or natural feed supply system in this particular case. So what happened, the whole aquatic species, all the farming units, they are entirely depending on the aeration and the food that we feed, that we are providing. So this aeration is very important, it has to be there, and you have to be very cautious whenever you will be designing aerator units, aeration units. So the number of aerators, that is actually ample enough to make the DO level of the system around 4 to 6. Try to do it, and if not, at least try to make it 2 to 3, so that the oxygen availability for, and it also depends upon the aquatic species that you are culturing. Sometimes tilapia can sustain a very low diesel oxygen level, this type of fishes, but there are certain type of fishes which cannot sustain DO level less than 4. So in order to identify, in order to go for the aerator unit design and all, you have to understand what are the aquatic species that you are culturing in your system. Carbon dioxide removal system, degasser at the end, which is very important. The water supply system, proper conduit lines and all. Water testing kit is very important to get to know about what are the parameters, the quality of the water after even being the treatment is being done. The inputs like seed, feed, additives, or the supplements are also involved with it. So this is a typical design of a recirculating aquaculture system. As you can see, from the pond, if you see from the pond, the water is coming to the first mechanical filter. In the mechanical filter, all the suspended solids or the heavy materials are actually taken out, and then all like the particles which are having certain like specific gravity, and also specific which are having higher than a particular size, is being taken care by the this particular unit. And then it comes to the UV filter, where it kind of work on the amount of microorganism present in the system. Then it comes to the carbon dioxide strippers, and also then to the biological units. This is not fixed. This actually varies. The place of this individual unit varies with the type of design or the type of target species, with the type of wastewater quality that you are expecting. So this is not fixed. Okay. And in the biofilter, we normally use see at the end where is this there is this split loop design biofilter is provided. In this biofilter, it can be moving bed biofilm reactor, it can be membrane bioreactor. So there are different options. Okay. So what is this moving bed biofilm reactor? What is membrane bioreactor? Maybe you can discuss. Well, I cannot discuss about all these things, all this wastewater treatment technology at this moment. Maybe later on in the later lectures you will find it, or else you can Google it, like what is moving bed biofilm reactor, what is membrane bioreactor, how it works. Okay, so I am giving a very brief about it. So normally we provide it with the different biomedias. It's like a plastic normal coils we provide. In this plastic coil, it has a very high specific surface area. So, and also because of providing enough amount of aeration and the amount of nutrient present in the wastewater, what happened, different kind of nitrifying bacteria will grow on its surface. Okay, not only nitrogen, different other type of bacteria will also grow on the surface of this biofilters, biomedias. So in this biomedia, so this nitrifying, this bacteria, what they do, they consume the nutrient present in the wastewater, and they convert that chemical composition to the to their biomass, right? Whatever they are in the nutrients present into this wastewater, they convert it into their biomass, and that biomass is easily separatable. So by this way, we can get rid of the nutrient present in the wastewater, and wastewater can be purified by this way. So then this wastewater is again taken back to the tank. So this way the treatment of wastewater is happening, and after then the treated water is again circulated back to the tank. So that is why it is called recirculating aquaculture systems. Now this is this is I'm discussing this system as a gross. Okay, so as a whole. There are individual units which are varied, like depending upon it's a altogether different type of systems depending upon the expectation of the customer, or expectation of the buyer, or expectation of your design farm and all. You can see this is another typical example of high-tech marine recirculatory aquaculture systems, where you can see the fish tank, both of the fish tanks are having 12 cubic meter of volume, where the water which is coming out of the fish tank is introduced to the unit A and B. If you can see, the first, the microscreen drum filter, from there to the pump reservoir, that arrow sign is showing, it means the pump. So, it is taking that water from after the screening is done in microscreen drum filter, that water is taken to the number C, which is a carbon dioxide stripper. After the carbon dioxide stripper, it is coming down to the protein skimmer. Through protein skimmer, it comes to the nitrifying moving bed biofilm bioreactor, MBB or MBBR sometimes it is called. In MBBR, you see this small black thingies, where actually those are actually different biomedia or which is involved. In this biomedia, there are a lot of different type of microorganisms there. So, these microorganisms, what they do, they consume the ammonia or consume the pollutant present in the wastewater, and they convert it to the nitrate or nitrate, and also even in certain places this if somehow anaerobicity can be prevailed, the anaerobic in that condition, the denitrifying microorganisms can also start working on it, and nitrate can also be converted to the dinitrogen gas or N2 gas. Okay. So, once it is possible, once it is converted to the nitrogen, what happens, all the ammonia is, all the nitrogen species is removed, right, from the system. Then it goes to the number F, which is like the oxygenator, low head oxygenator, or the, like, simply if I say it's a type of aerator. So, you are supplying the oxygen to your system, and then it goes to the G, which is another pump reservoir. From there, the pump is actually taking the water to the taken back to the fish tank. So, that is the clean water again. So, this way the water circulation is taking place. Other than that, if you go to the red line, if you consider into the red line, where the mostly the anaerobic and the like anoxic zone is prevailed there. So, what is happening, all the sludge, all the the microscreen filtered sludge which is producing there, that is come to the sludge collection tank, which is number H. From there, it goes to the sludge digestion tank, which is like A, and from I and from there it goes to the Dianamox fixed bed outflow bioreactor. So, that is also a type of bioreactor, where Dianamox is like it's a type of microorganisms which are present in the system, which actually utilize the water or whatever the pollutant present in the incoming waste, and that they utilize and they convert it to the further byproducts. And this from there it goes to this biogas collecting units. You see the number K, and from there if you see they again like the water which is like collecting which is purified in the number J, or like the fixed bed outflow bioreactor, that is also again coming back to the this initial microscreen drum filter, and by this way the whole recirculating aquaculture system is working. So, this is only a type of design that is available in the literature. If you go for Whitehall et al. 2009, the reference is given at the end. They have nicely designed this system, and it is already available, and this kind of designs are already available. So, giving you another model technical specification for tilapia culture in recirculatory aquaculture systems. So, suppose we are targeting the Nile tilapia. The tank size is say like 6.6 to 6.6 to 2, like 6.6 like width, length, width and height. Total volume of around 90 meter cube. Total stocking size is fingerlings of 6,000 per tank. Survival rate is around 90%. The food conversion ratio 1:1.3, and the culture period of around 6 to 7 months. Cost of seed around 4 rupees per piece, and cost of feed is around 30 rupees per kg at this moment. Total feed required will be like 3.2 metric ton, and the size of the time of harvest will be at the time of harvest will be around 500 gram at the end of 6 months. So, total expected biomass will be 2.7 metric tons. So, you can see the difference there, and also the sale price will be around 140 rupees per kg in general. So, that is how this is just giving you some basic example of how we do the calculation. It is not fixed for any particular region or all. It can vary drastically place to place, and in different consideration and design values that we input. So there are like capital cost which involved with designing of this RAS. There are like input cost, there are like recurring costs, there are non-recurring cost, and based on that we go for the depreciation value calculation, and we do the total amount at the end, how much is the cost for each unit or of this RAS and all. So I'll be discussing about more in details about this cost analysis of aquaculture sector, aquaculture farm, how we do it, how we can do it like more precisely, so that we have in-depth idea about the amount of benefit that we are getting out of the system. The demerits and demerits of RS technology, in general the advantages which involved with the RS technology are, it is low water and land requirement, prolonged durability of the tanks and equipments, easy rectification of water quality parameters, reduced direct operational cost associated with the predator or parasite control of the feed, because which is not possible in case of open channel or in case of open culture and all. It is not possible in this case of only in case of RS we can control these things. We can have a very high stocking density and very high food to feed conversion ratio. You know what is feed conversion ratio, right? The amount of feed the aquatic species is taking and the how much is like what is the portion of it is actually converted to its biomass. So that is called the feed conversion ratio. So that is also very much high in this particular case. It reduces the requirement of antibiotic, pesticides, or the vaccine uses in the system. It improve the health and also the production of the fish species or the any cultures aquatic species that we are doing in the recirculating aquaculture system. But it comes with some disadvantages. The major disadvantages is, but because it's completely artificial, it's completely anthropogenic activity, like complete human presence is required, or the complete automation is required. In that automation we have to make sure that it has uninterrupted power supply. If it doesn't have uninterrupted power supply, what will happen if for some time, if even for very few minutes the aeration system starts not working, or say like feeder is not working for like 1 hour, like 2 hours, 3 hours, say something like that. So depending upon the species and the maturation stage, it can cause drastic effect in your system. It can cause complete complete loss of your aquatic output from your farm. So that is a very big of a disadvantage related to the RS technology, and also it involves a very high capital cost in the beginning, okay, compared to the ponds and raised beds. But with time, definitely with the benefit that you will be getting from selling your product and all, so the payback period is also less. So but it involves with the basic high capital cost, which actually problematic issues. So it reduces the overall environmental impacts and improves the food security, as we have discussed, and it reduces the utilization of the therapeutants and it facilitates high food conversion ratio and production rates. Most of the fish species can be reared using the RS technology. So what will be the takeaway message from this lecture? That the recirculating aquaculture system, it's a high-tech, intensive, closed aquaculture system which are being practiced all over world nowadays in all the aquaculture farm. Most of the aquaculture farm, where we try to avoid any kind of environmental impact, where we try to improve the food security, where we try to involve the minimal use of land and water, and also try to reduce the utilization of therapeutants, where we want to facilitate the more higher amount of fish conversion ratio. So all these cases we introduce the recirculating aquaculture system, and it will give us some economic benefit as well. So that's all for these are the references that you can go ahead and you can search for more understanding about the system, and that's it for this lecture. So we'll discuss about more in details in the coming lectures. Thank you so much.